Okay, let's take a look at the homework that is due on Friday, September 16th. I'm not going to go through 1, 2, 3, or 4. I think you have a chance to do those. Just remember, everything is based on the idea that CD is the perpendicular bisector of AB. All right, so just remember what that means, and you should have a chance to do 1, 2, 3, and 4. All right, going to 5, 6, and 7, I really didn't particularly like, especially 6 or 7. But I will say on number 5, so I'll go over that one. And if you get 6 or 7 wrong, don't worry about it. I won't penalize you too much for that because I think they're kind of confusing a little bit. But let's look at number 5. All right, so number 5, if you look here, you can see that what they're asking is to tell whether the information in the diagram allows you to conclude that C is on the perpendicular bisector of AB. Explain your reasoning. So if you look at number 5, we do know that AP and BP, so this segment and this segment are congruent. The reason why you know they're equal is because of this little line. All right? So hopefully you watch this because this line is what tells you that these two segments are actually congruent. Okay? So those are actually congruent. However, the fact that this side is 8 and this side is 7.
Please excuse the interruption, any staff, teachers.
All right, one thing we don't know whether these angles are 90 degrees. We're not given that piece of information. Now, it may appear that they are, but the fact that these sides are different tells us that this is C is not on the perpendicular bisector. So what we'll write is though C is not on the perpendicular bisector, because if it was, AC, segment AC, and BC would be congruent. All right? There you go. There's number 5. All right, let's look at numbers 9 and 10. All right, so looking here again, let's look at the diagram. And I want to just take a look here. These little lines, what these indicate is that this segment, RV, is congruent to TV. Right, that's what these lines mean. So when you see that, that means congruent. They are congruent to one another. All right, so we know that. All right, so if you know the length of one, you know the length of the other. Let's do number 9. SV, it says, is perpendicular. Remember, this means perpendicular to RT. So let me erase this now. All right, so we have SV, which is here, is perpendicular to RT. All right, so we have a right angle here, which means we must also have a right angle there. Let's see, VR is congruent to VT. We just talked about that. So that means that this is 8, if the other one's 8. And to find SR. So we want to find the length of this one. So we want to find this length. Now, if you notice here, what we have are two right triangles. So triangle SVT and triangle S, V, R are both right triangles. It dawned on me when I was looking over this homework, I don't remember if you guys, my geometry class this year, I don't know if you ever have talked about right triangles and Pythagorean's theorem, a squared plus b squared equals c squared. I wasn't sure if you even did that, because back when I taught algebra, it used to be part of the curriculum. I'm not sure if it is now. So that's why I'm going over number 9 and 10, because, especially number 9, because it's something you might not remember. So pay attention here. All right, we're looking for SR. Now, again, we have, we know that these two triangles are the same. They are congruent to one another, right? We can actually find SV, right? But we know that those triangles are congruent to one another, so really we don't need to deal with that. We know that if this side is 17, then this side over here must also be 17. So SR is equal to 17. All right, SR is 17. Now, if I want to find VS, which I know it doesn't ask you this here, but I'm going to show you how to find VS. I'm going to take one of these triangles, and I'm going to do a squared plus b squared equals c squared. Hopefully you've seen this at some point in your career, all right? And what I would do is have 8 squared plus b squared is equal to 17 squared, and then I would have 64 plus b squared is equal to 17 squared. All right. And let me do, what is 17 squared here? $289. Good. So that's 64 plus b squared is equal to 289. I'm going to take away 64 on both sides. So I have b squared is equal to 225. And remember, I have to take the square root. B is equal to 15. So we actually could find out that this side is 15. I know it didn't ask us that, but now you know anyway. That side's 15. Because we knew it's a right triangle, we could use a squared plus b squared equals c squared. All right. Now also, looking at number 10, it says, what can we conclude about point U? Well, if I continue, that must be on the perpendicular bisector because of the fact that these are congruent. So sides RU and TU are congruent. U must be a point on the perpendicular bisector. So it must be a point on the perpendicular. Let's look at number 11. All right, we're looking for AD. And we're told that AC is the perpendicular bisector to BD. So if that's the case, then I know that BC and CD are the same. So they're both 3. I'm looking for this side over here. If this is the perpendicular bisector, this is a right angle, this is a right angle. So I have two right triangles. When you have a right triangle, so when you have a right triangle, you can use a squared plus b squared is equal to c squared. So in this case, we're going to do 3 squared plus 4 squared is equal to, we're going to call this x squared, right? So we're going to have 3 squared is 9, plus 4 squared, which is 16, is equal to x squared. 16 plus 9 is 25, is equal to x squared. Take the square root of both sides, and 5 is equal to x. So we have x is equal to 5, so BD is 5. I'm sorry, AD is 5. There we go. Okay, for number 14, it says, is AC a perpendicular bisector? Check for right angle. So let's do that. So they're asking basically, is AC a perpendicular bisector? So sometimes you're missing a side and you can use a squared plus b squared equals c squared to find the side. Sometimes you're given all the sides of a triangle and you can use that formula to determine if it is a right triangle or if there is a right angle. So if I have the sides 5, 12, and 13, I want to think to myself, is there a right angle? So is this a right angle? Is it 90 degrees? So how we can check, is it a right triangle? If this is a right triangle, then this would be a right angle. So what I can do is plug it into the formula. So I can ask myself, is 5 squared plus 12 squared equal to 13 squared? Is that true? So if that is true, then this is a right angle. Well, let's do it. What's 5 squared? 25. What is 12 squared? 144. What is 13 squared? 169. So what do I have on the left? 169 is equal to 169. So that means, yes, this is a right triangle, which means that this is a right angle, 90-degree angle, which means that AC is the perpendicular bisector because these are equal, right? These are equal to one another. BC is congruent to DC or CD. And we have 90-degree angles. That means AC has to be the perpendicular bisector. So yes, AC is the perpendicular bisector of BD. What? AC is the perpendicular bisector of BD. I know this homework was a little tricky, so I'm going to be easy on you with the grading. Just do your best on it, okay?